So in this lecture we will discuss about what will we do when an all zero row comes in the truth table. So how can we assess the stability of the system when we get an all zero rows in the root table? So an all zero rows indicate that some roots of the systems are lying on the imaginary axis or j omega axis. So when an all zero rows comes in a characteristic equation or in a system, that means that the system having poles on the imaginary axis, and the system may be marginally stable or limitedly stable. So we will discuss a problem now. So here the characteristic equation is given as q of s is equal to s cube plus 2s square plus 4s plus 8. So first step is we have to find the root table starting from s cube, s square, s raised to 1 and s raised to 0. So first we can write the coefficient of s cube 1. Next alternative element is coefficient of s raised to 1, that is 4. Now the coefficient of s square is 2 and coefficient of s raised to 0, that is 8. Now we can find the coefficient corresponding to the row s raised to 1. So that will be 2 into 4 minus 1 into 8 by 2, that is equal to 0. So the first element is 0. So we have to find the next element also. So when we find the next element, we don't have any third column here. So the elements of third column here and here are 0. Actually we don't have any element here. So in order to find it, it will be 0 only. Okay. Since we are not having any third column, this element will be 0. So here we got 0 in the all 0 row, and all 0 row is present in the root table. So what we will do, and all 0 rows is present. So a situation like this comes, you have to consider the row just above this all 0 row. So we have to take the row, or we have to consider the row that is just above this all 0 row. So what is the row? So here the coefficients are 2 and 8. Corresponding to s square, the coefficient is 2, and corresponding to s raised to 0, the coefficient is 8. So we can write the equation corresponding to this row, that is 2s square plus 8, that is equal to 0. So we got an all 0 row in the root table. So when a situation like this comes, you have to consider the row just above the all 0 row, and here our coefficients are just above the all 0 row. The coefficients are 2 and 8. 2 is corresponding to s square and 8 is corresponding to s raised to 0, that we know. So we can write that equation 2s square plus 8 equal to 0, and this equation is known as auxiliary equation. Okay. So your auxiliary equation is 2s square plus 8 equal to 0. Now what we have to do? Now you have to find the derivative of this auxiliary equation, or first differential of this auxiliary equation with respect to s. So find dA by ds, that will be 4s plus 0 equal to 0. So when you find the derivative of this auxiliary equation, that will be dA by ds, that is 4s plus 0 equal to 0. Now replace this equation here. Replace the coefficient of this equation here in the all zero row. So as I have already told you, the all zero row indicates that some poles are lying on the imaginary axis. Some poles of the given system are lying on the imaginary axis. So we can find out what are the poles that lying on the imaginary axis by taking the auxiliary equation that we will discuss now. So now I am replacing, or I can rewrite redraw the root table with given values s cube, s square, s raised to 1, s raised to 0. Now 1, that is the first element, 4, 2, 8. Instead of 0, 0, I can write these values. Okay, instead of 0, 0, that is corresponding to s raised to 1, find the or write the coefficients of auxiliary equation, that are 4 and 0. Now if you find the coefficient corresponding to s raised to 0, that will be 4 into 8 minus 2 into 0 divided by 4, that will be 8 itself. So now in this first column there is no sign change. In this first column there is no sign change, but we have two roots are lying on the imaginary axis and the other one root is lying in the LHS. These two roots are lying on the imaginary axis and the other root or other pole is on LHS of S plane, left hand side of S plane. Since there are no sign changes. Okay, so when an all zero row comes, you have to consider the row just before the all zero row, and you have to find the auxiliary equation. So we can find the auxiliary equation by this, and so here the auxiliary equation is 2s square plus 8 equal to 0, because 2 is corresponding to the 2 is the coefficient corresponding to s square and 8 is the coefficient corresponding to s raised to 0. Now find the derivative of auxiliary equation with respect to s. Now replace the coefficient of this, that is dA by ds, instead of all zero rows. Now complete the root table. So this indicates that this all zero row indicates that there are poles on the imaginary axis, and if by completing the root table there is no sign change, the other poles are lying on LHP. So we got there are no sign changes in the root table. That means the other or remaining poles are lying on LHP, but some roots are lying on the imaginary axis. That roots we can find using the auxiliary equation, because the roots of the auxiliary equation will be the roots of the characteristic equation. So if we solve this auxiliary equation, we will get s is equal to plus or minus j2. That means that these two are the roots of the given system or poles of the given system that are lying on the imaginary axis, and the other pole, since the equation is s cube plus 2s square plus 4s plus 8, there are only 3 poles for the given system. because the highest power of S is 3 and order of the system is 3. So only there are 3 poles for the given system. In that, 2 poles are on imaginary axis and the other pole is on LHP, because we don't have any sign change in the truth table. Okay, first column of truth table we don't have any sign change. So the other pole that is lying on LHP, but 2 poles are lying on the imaginary axis. Hence we can say that the system is we can say that the system is marginally stable. We can say that the system is marginally stable. Marginally stable means it is not fully stable, but it's not unstable. So the stability condition is the system is marginally stable.